Okay. Okay, now it's live. All right. So I'm assuming we're going to be live now.
I think I'm connected here, so.
Okay, then I'll just take this here. This works. Yep, I guess this works. It's time now? Yeah. Good afternoon, everyone. Yep. Okay, I guess this works. Yeah. Good afternoon, everybody. Welcome to Google Developer Student Clubs here at Heriot-Watt University. We welcome all those who are attending here in person as well as online. My name is Chandrasekhar. You guys might know me by CSK. Welcome to the Creating Your Own Web App series for the second session, where we'll be covering more of the front-end concepts. This series is hosted by Gaurav Gosain. I'd like to give it over to him to explain more about the session today. All the very best.
Thank you, CSK. So again, thank you everyone for attending here as well as online. So let me introduce myself first. I am Gaurav Gosain, a recent graduate with a BSc honors in computer science, specialized in AI. I would like to consider myself an enthusiast in web dev and technologies related to web development. I like to know what goes on behind the scenes. So this is, as CSK said, this is the second session in the series where we'll be covering most of the front-end concepts. So before we start, here's a QR code to a template repository I have created. You all can visit the template repository. The repository contains a starter code for a Next.js project that is set up with Material UI and Tailwind CSS that we can use later in our session. I can show you how the GitHub link looks like. So this is how the GitHub link looks like. It's a template repository. If you're not signed into GitHub, you might not see the green button over there that says use this template. Although if you do have an account, do log in and you can see the button where you can click the use this template button to basically clone the repository onto your own GitHub account. Another way, if you don't have an account and don't want to make an account, you can click on the code button and download the zip file from here. That will also work. I'm going back to the slides. While we cover the slides, you can basically set up the project in the background if you want to, or you could even look at the recording as this is live streamed. You can look at it later and code along later as well. So the agenda for today, we start off with a welcome. We move on to recapping, a basic refresher on what we did in the last session. Then we move on to a new concept called rendering. What is rendering relative to Next.js and React.js? Then we cover what is the network, how can you deploy your Next.js app after it's done, how can you share it with the world, you can deploy it on a server or a network or on the network. Then we move on to creating your first Next.js app. This will be complete with setting up Material UI as well as Tailwind CSS, which are UI libraries. We'll discuss more on that later. This will be followed by a short coding session where we live code. We make basic components, see how fundamental React concepts work, such as props, states. Short Q&A session where you can ask all your doubts, or we can probably debug whatever issues you're having setting up your Next.js app. So before we move into making our Next.js app, let's recap a bit from what we did in the last session. In the last session, we had defined with a very simple definition of what is web development. Web development is basically building sites and applications for the World Wide Web. We as developers, we write code, which is basically either for the front end or the back end. Front end is what the user sees when a client visits your website. He lands onto something, he can see something, that's called the front end. Whatever the server receives as an input and sends back as an output is the back end. Back end mainly deals with data manipulation. For example, if you want to render a simple line of text, say make it bold, or change the color of the text. That is part of the front end. On the other hand, if you want to say visit like a /about section on your website, or a /contact us page, that information gets sent to the backend, and the backend responds with the corresponding HTML to serve to the client so that they can see the information they need. Next, since the dawn of the World Wide Web, there have been or initially there were two major web technologies used, namely HTML and CSS. HTML, which stands for Hypertext Markup Language, CSS standing for Cascading Style Sheets. Later, when the web evolved, it matured a bit. There was need for interactivity, which is why a scripting language was designed, which is known as JavaScript. HTML deals mostly with the content and the structure of your website. CSS deals with the styling, or how the website is presented to the end user. And JavaScript is more like the brain of the website, where it handles all the logic and the behavior. So when a user interacts with something, it's most likely JavaScript that handles the interaction. So in the last session, we also discussed something called the DOM, or Document Object Model. So when an HTML page is passed to the browser cannot directly interpret what is there in the HTML file. So it has to parse it into a tree-like structure called the DOM. So you can see there's a very simple example of an HTML page there, where HTML is the root node, or where everything in your HTML file is defined within. The body is the entry point of your website. Basically, everything inside the body is displayed on the web page. Then there are a few other tags like H5, H1, and UL. H1 to H6 are basically header tags, with H1 being the biggest tag and H6 being the smallest tag in order. So over there, H5 is a small header tag, while H1 is a relatively bigger header tag. Then we have an unordered list with 3 children, or list indexes. So you can see the HTML over there is passed by a browser as a DOM, or a document object model, which is a parent-child relationship. You can see that there is an HTML node, which is the parent node, which has a body, which is the child node, and it has another child node that is div, and so on. In a similar way, body can also be considered the parent node of the div. Now, moving on, how the DOM is rendered on the web page. The DOM is parsed into a user-friendly interface that can be seen on the client's computer. The DOM is an object representation of the HTML elements. As we discussed before, it's a tree-like structure with parent-children relationships. What the DOM enables us to do is it provides us with DOM functions, which in turn enable us to manipulate the DOM. Manipulating the DOM would change how the DOM would look to the end users. Now, manipulating the DOM, we had seen that in the last session, that there is a way to manipulate the DOM directly with JavaScript, where you would have to select a DOM node and say you wanted to add a new element as a child to the DOM node. You would have to create a new child node and then append the child node to the parent element, and so on. So that would consist of multiple steps before you could actually even render something to the screen. So that process of doing that is called imperative programming. So there are 2 major paradigms of programming. One is called imperative. The other one is called declarative programming. So the way of manually telling the browser all the steps in order to manipulate the DOM is what we call imperative programming. On the other hand, declarative programming is more like telling the browser what you want as an end result, and the language tries to figure out all the steps, intermediary steps in between. So one of the most popular declarative libraries for JavaScript, for building user interfaces for JavaScript, is React. So building UI with components. So the development and design practice of building user interfaces with modular components is usually called component-driven development. It is a very popular form of development in terms of building user interfaces. What this means is we start off by building smaller components, and then we join them into bigger components, somewhat like Lego blocks. So you take like small blocks and join them into a bigger block, and finally you have multiple of these blocks rendered onto a screen, which can form like a proper page. You can assemble into a screen, basically. So here there is a small example of a media component, which somewhat has like an image on the left, some content on the top right, and a button on the bottom right. So the main component can then be broken down into smaller components that build up the bigger component. For example, here we have the image description and button component separated. This is a very simple example. In a similar way, in a website, you might have like tens of components combined together to form like a complete web page. So now moving on to how Next.js deals with your code. So we discussed in the last session, you can write React code in another language that is very similar to HTML. It is called JSX. It is a template sort of where you can integrate JavaScript inside HTML-like components. So there on the top left is a very simple example of a functional component that has a single div element. A div element is basically just a wrapper for your for whatever content you want to put in. So the div element has a simple line of text there. For example, DX of the future, DX standing for developer experience. So what a compiler does is a compiler is something that translates or converts one language or one piece of code in a language to another piece of code in another language. In this case, although it's a compiler, but it is compiling from JavaScript to JavaScript. The first part of the JavaScript being JSX. The problem with JSX is although it makes the developer experience very easy and it makes it easy for us to write code for the browser cannot natively understand the JSX part. So we have to do something called compiling, which basically compiles or changes the code from JSX into JavaScript, like pure JavaScript that the browser can actually understand. And based on that, the result of the compilation of JSX is pure JavaScript, which looks something like on the top right over there. Now this compiled code, although it is efficient enough, it still has a lot of extra spaces and tabs and comments, which are not really required for the browser to interpret the JavaScript. Our goal as a web developer should always be to reduce our bundle sizes, which basically means that make our code as efficient as possible. So make it as small as possible so that it can be sent faster to the client. So the website basically speeds up if you have lesser code. So the next step after the compilation process is called minifying. So basically minifying removes all the unnecessary information from the compiled code, like the spaces and the tabs and the new lines. So you can see that the entire block of code over there, which was very unnecessarily long, like it's well formatted, you can read it, but it's not necessary for the browser, as the code can still be read in the same way in the minified version. The next step to minifying is bundling. So basically, when you write code in component libraries like user interface libraries like React or Next.js, you can separate your code into multiple small components, but the browser does not need to read them as separate components. You can have the entire code in a single file. So that's basically what bundling does, is it compiles or combines the multiple JavaScript files or TypeScript files, for example, into a single JavaScript file. But now, again, a problem with this that arises is that the compiled bundle is very huge and it can't be sent as a single file to the client. That's where code splitting comes into action. Code splitting is basically splitting the big file into smaller chunks so that it can load faster on the user's or the client's device. So let's move on to the next topic. What is rendering? So we won't be covering rendering in general, but we'll be covering rendering in terms of Next.js and React.js. So we'll also be discussing about the different rendering options that Next.js provides us with. So as discussed before, JSX cannot directly be read by the browser, neither can JavaScript as a user interface. So there is an unavoidable unit of work to convert the code you write into pure HTML. So this HTML representation of the UI is then served onto your client, which the client then parses as a DOM and then is finally seen by the user. So this process of converting your compiled code into pure HTML so that it can be rendered on the screen, on the user screen. This process is called hydration. So hydration is a very important step in any React JS app. So rendering can take place in multiple formats or multiple ways. It can either take place on the client, which is like the client or whoever visits the website, their device. It can also happen on the server, which is a different form of rendering. Um, Even on the server, there are different ways that the code can be compiled. It can be built ahead of time so that you have predefined templates, like sort of templates of HTML pages that can directly be sent to the client when they ask for it, or it can be compiled on every request. So every time a new user lands on the page, it is compiled again and sent as an HTML file. So with Next.js, there are three main types of rendering methods. The first one being server-side rendering, static-side generation, and client-side rendering. Now, server-side rendering and static-side generation together, they are also referred to as pre-rendering because the fetching of all the external data and the transformation of the React components into HTML happens before the result is sent to the client. So it's all done on the server. Pre refers to before, obviously. So before it's sent to the client as HTML. So now let's see why do we have two types of rendering methods. So one is client-side rendering, the other one is pre-rendering. Client-side rendering refers to the rendering method where where when the client initially visits the web page, there is nothing loaded on the screen. It's a blank canvas basically. So in client-side rendering, which is basically in a standard React application, the primary method of rendering when you just work with React.js without Next.js, that is just a React application, the primary method of rendering is always client-side rendering. So as you can see from the diagram, there is an initial UI that is blank. Basically, when the user visits your website, you can see nothing, just an empty page. And only when all the JavaScript is loaded onto the web page, you can see something that is interactive or that has some meaning. So when in a standard application, when someone in a standard React application, when someone visits a browser, visits a website on a browser, they receive an empty HTML shell from the server along with JavaScript that is loaded in later. Now, this is very different from pre-rendering. What pre-rendering does is, by the way, in Next.js, every page is pre-rendered by default. So that is a plus. Pre-rendering refers to the process of rendering HTML pages in advance. And whenever someone visits a web page, instead of having it done all by JavaScript on the client's device, there is partial hydration that takes place. Hydration is the process we mentioned earlier. So partial hydration refers to um, just the framework of the user interface, or like a very non-interactive version of the user interface being rendered first on the client's device. So there is initial UI. In the diagram, you can see there's an initial UI where you can see the like button is grayed out. What that means is there is a template, somewhat of a template that is rendered on the client screen when they opt in for pre-rendering. That is not interactive, but once all the JavaScript has loaded in and it can understand what to do and how to make the website dynamic, then the like button over here turns into an active state. So basically, a fully client-side rendered app, a user will see a blank page when they first load in, while when they opt in for pre-rendering, pre-rendering will render a skeleton of an HTML and send that over first, and then finally, when JavaScript is loaded in, make the page more interactive. So, as we discussed before, there are two types of pre-rendering. One was server-side rendering, and the other one was static-side generation. Um, Both of these options are supported by Next.js by default. So server-side rendering, as we said before, the HTML of the page is generated on a server. The difference here is the HTML is generated on each request. So basically, whenever a user visits a web page, the server has to basically calculate or process the information, generate an HTML page, and send it over. So it generates HTML, the HTML page, JSON data, as well as JavaScript, and sends it to the client so that the page can be made interactive. On the client, initially the HTML page is shown as a non-interactive version of itself. But when JavaScript and the JSON data, as well as other components that are passed on from the server, are loaded in properly, then hydration takes place. That is, the web page becomes more interactive. So in Next.js, you can opt into server-side rendering by using a function called server-side props. So it is basically a default function that you can define in any Next.js component, which tells Next.js that you want to render something on the server before sending it as HTML. We'll look more into this in the later sessions when we actually start building the web application. So the next form of pre-rendering, which is static site generation. Static site generation is very similar. I would say it's not very similar, but it's similar to server-side rendering. It is different in the context that all the HTML pages here are pre-rendered and saved on some sort of network. Network in this case being a CDN or the edge, for example. And every time a user requests something, the browser basically asks the CDN for the information, and the CDN will deliver the HTML. We'll discuss more about CDN in the later slides. So in Next.js, you can also opt into statically generated pages by using the function called getStaticProps. Again, we'll discuss about this more when we actually start building the application. Another form of static site generation that is very commonly used for, suppose you have an e-commerce website. So basically you have multiple pages that remain same over a long time, but you might eventually add more pages. For example, you have like a catalog of 100 products, and you don't want to, and you know that the content for those pages will remain the same, but you might add more products later in your catalog. So in that case, there is something that Next.js offers, which is called incremental static regeneration, which is basically you can list out all the pages that you want Next.js to pre-render, so that whenever a user visits a product page, it is rendered very quick. Now, it is a very subjective choice of what kind of rendering you want to opt into. There are different use cases that might require a server-side generated component, while other use cases might require something that is statically generated, while some use case might even require something that's rendered on the client side. The good thing about Next.js is that you can choose whatever kind of rendering you want on a page-by-page basis. So say you have a landing page that has a lot of static content. You can just opt into a static site generation for the landing page, while you have another page that has more dynamic content that changes with time. For those pages, you can opt into either server-side rendering or client-side rendering. So moving on to the next topic, what is the network? In the previous session, I believe we discussed what a network is in very brief and a very informal and simplified way. Now let's have a deeper look on why you would need a network when you want to deploy your application. Deploying is basically the process of publishing your application to the World Wide Web so that other users can visit it. So you can think of the network as a linked web of computers, basically, or servers for that matter, which are capable of sharing resources. In the case of a Next.js application, your application code can be either distributed to origin servers or the CDN, or there's something called the edge, which is a relatively new concept. We look into these different server methods in detail now. So what are origin servers? We had discussed this in the previous session. Servers are basically the main computer that stores and runs all the code you have. Whenever a user visits your website, it requests the server for a particular page, and the server responds with the appropriate page. So here we use the term origin just to distinguish between the different types of servers. An origin server is basically just a server. The other methods are also servers, so it's easier to distinguish when we use the term origin. So when an origin server receives a request, it does some computation in the backend and gives you the result. Now, the computation work can become very expensive real quick. If your website has a lot of content, the server might have to work really hard in order to generate the static HTML page to send over to the client. So to reduce some of this computational expense, there was something called the Content Delivery Network, or CDN, introduced. So now, what is a CDN? A CDN stands for Content Delivery Network. So it can store all kinds of static content. Like, for example, you can have static HTML pages or images, for example, stored on a CDN. The good thing about CDN is it's a distributed sort of network. So it's not a single computer that's hosting everything. The CDN is distributed across different locations. So, for example, if you're closer to say Washington, the page will automatically try to find whatever CDN network is closest to your geographical location and try to request the assets from there, so that your web page can load faster than it would when it was just hosted on a normal origin server. Now, the edge is a relatively new concept in terms of the network. Traditionally, it was always the origin server for hosting your code and the CDN for actually getting static assets for your website to load faster. The edge is sort of a middle ground for both. Uh, the edge refers to the fringe or the edge of the network. It's pretty self-explanatory, the name. So what the edge stands for is it's also very similar to the CDN in a way that it is distributed across different locations. So um, when someone requests something from the edge is also capable of running code. So unlike the CDN, which could only statically store stuff, so that it could only store an HTML page that was already generated, the edge is actually capable of processing something and actually running code in the backend as well. Although in Next.js, the edge is not really completely supported as of yet. There is something in alpha called the middleware. So middleware is basically a way to run your code on the edge, and it is even capable of rendering React components on the edge, so that you can just request for a page and the React components will be rendered on the fly, so that the load times of your page will reduce by a lot. So moving on to what front-end tools we'll be using today. So the two major front-end tools we'll be using today is Material UI and Tailwind CSS. Um, so what is Material UI? Material UI is something that adopts the material design from Google. Material design is just a set of rules Google has defined that show how a website, how a component or like the user interface should look like. Material UI is a UI library in React that adopts this design. The good thing about Material UI is it is open sourced, so it can have a lot of contributors that can contribute to the project, fix bugs. Um, it also comes with a lot of pre-designed components that you can simply import in your React app and drop into your application. They're already production ready. You can modify them to your heart's content. The second thing that we're using is Tailwind CSS. This is developed by Tailwind Labs. It is a utility-first CSS framework. What that means is that you can simplify writing CSS for your websites. The good thing about Tailwind CSS is it is very optimized. That is, it doesn't add a lot in terms of bundle size when you actually try to deploy your application. So it is very lightweight, basically. Um, we will also be making use of uh, material icons, which is basically a set of handpicked icons by the MUI team, which we can use in our application as well. So who uses Material UI? There are some big names over there: Amazon, Netflix, uh, a subsidiary of NASA. I think they have a small website that uses Material UI. There's Unity, Shutterstock, Spotify. There are a lot more. These are just a few examples listed. So MUI, it offers a comprehensive set of UI tools that help you ship your website much faster. One of these tools in this suite is called Material UI. Material UI is basically a set of predefined components that can be modified. You can adapt your own design language to it. Um, as well as we'll be using material icons, which is a great set of uh, icons that come with the MUI suite. Uh, where can you learn about material UI? You can learn about material UI from the docs, the official documentation from MUI. You can visit the website or you can scan the QR code. It will take you to Material UI's website. Um, so if you want to learn, you can head over to the docs and Material UI. They have excellent documentation. As I said before, it is open source, so there are a lot of contributors that help make the project better. Uh, the documentation walks you through what Material UI exactly is, how can you integrate it with different kinds of front-end frameworks. Uh, there are a lot of components that Material UI comes with by default. You can head over to the component section on the left side, on the bar on the left side, and you can see a list of all the components that Material UI offers. For example, you can head over to any of these. It tells you a brief description of what it is, how you can modify it. There is code provided with each of the examples, so you can simply click on the button and view the full source code on how to recreate whatever is hosted on the website. There's also another helpful button over here that says edit and code sandbox. Code sandbox is basically an online environment where you can run JavaScript or React code. Um, so yeah, basically you can mess around with this in real time. You can change the text, for example, to something else, and it should automatically update the view on the right hand side. So that's about what Material UI is and where you can read the docs about Material UI. So the next thing we'll cover is why Material UI. As I mentioned before, the documentation is pretty good. The biggest advantage is that the biggest advantage of a tool being open sourced is it can have great documentation, as anyone can go ahead and contribute to the project. There are over 2,000 contributors that have contributed to Material UI so far. It has great aesthetics. We can build beautiful user interfaces with ease. It follows Google's material design, so it is intuitive to the users how the flow of the website is or how the interaction should go. The customization part is also very important. It is very easy to customize whatever components Material UI provides you with. Um, Again, the accessibility is another big plus point for Material UI. Accessibility here stands for making your website accessible to people with disabilities. Like it supports screen readers and screen readers by default, so your website can be read by screen readers. Um, yeah, it promotes building for everyone, basically. Uh, Another big reason is the components that Material UI comes with are production ready. Basically, you can just put them in your React app and trust that it will work well, even when you deploy the application. So now moving on to Tailwind CSS. Tailwind CSS is another uh, CSS framework we'll be using. So Material UI will mainly be for putting in components in our web page, whereas Tailwind CSS will mostly for this session, at least, it will mostly be for positioning stuff on the screen. So basically adding more padding around something, adding a margin, or basically creating a flex box in CSS, or so on. So you can see that Tailwind CSS uh, provides you with a very easy interface to add styles to your components. How Tailwind CSS works is you give class names, or basically you define a class for a HTML element, and it will automatically apply certain styles to that HTML element. For example, if you wanted to make text inside some div component large, you would simply say that the class of that div is text-lg, which is pretty self-explanatory, as LG stands for large. So text-lg would make the text inside the div large, for example. Another great feature of Tailwind CSS is it supports dark mode by default. So you can style your components for both dark mode as well as light mode in this at the same time. Tailwind CSS also comes with other great features like you can make your a major challenge when it comes to making web design is that everything you do on your website should be responsive. Basically, everyone has a different device nowadays, and the screen sizes might be different. Someone might be viewing it on a projector, for example. Another person might be viewing it on his mobile phone. So the size of the website changes, and with that, the user interface should also change. What Tailwind CSS does is it provides you with a very simple API to interact with different screen sizes. So basically, there's something called breakpoints. A breakpoint defines a different screen size. So for every breakpoint, you can define different styles of your different React elements. Yeah, Tailwind CSS as well follows best practices. You can support all accessibility features. Most of the CSS features are supported by Tailwind CSS. If you have ever worked with CSS before, Tailwind CSS should be very intuitive. Although it is recommended that you first understand what CSS does in order to move on to Tailwind CSS. You can adapt Tailwind CSS to whatever sort of style you want. It is highly customizable. Yeah, exactly. It's very tiny. You never ship extra CSS, so your bundle size remains small. And it's responsive, as I mentioned before. There are extra states you can mess with. Uh, it avoids code duplication as well. So you can define a certain set of styles you want to reuse in your application. So that avoids extra code to be shipped to the client. Um, So you can learn more about Tailwind CSS in their documentation as well. They have excellent documentation. Uh, they even have a step-by-step tutorial that guides you through how to build a simple web page using Tailwind CSS. Um, Now we can move on to the code. So this is the component we'll be making today. It's a very simple component. There is a header with a picture on top, a name, maybe the time when the thing was posted, an interactive menu on the top right, which when you click, there might be menu items, a short description, a like button, and a share button. That's a very basic thing to start with. So if you have uh, if you have scanned the QR code that I had in the very start of the slides, which I can put on again. Basically, this template has Material UI as well as Tailwind CSS set up for you out of the box. So all you have to do in order to start writing your Next.js app is click on Use this template. It should take you to a page that looks similar to this. You can give it any name. For example, I'll call it Next.js demo. Now it's your choice if you want to share the code with others or if you want to keep it private to yourself. You can choose that. I'll choose to make it public. Now you can create a repository on your own GitHub account from the template. So what this does is actually clones everything that was in the GitHub repository. You can even read these steps in the description below the repository where it says you can click on the button and clone it basically. Now to install the cloned application locally on your system, there are a couple of ways you can do it. You can either click on code and you can download it as a zip file, or the more preferred way is if you have Git installed on your device. Git is basically something that you can use to clone repositories. So if you have Git installed on your system, what you could do is you could head over to your terminal. So if you have Windows, for example, you can install something called Windows Terminal. If you have Mac OS, you should have a terminal by default. So So how you can clone the website is by heading over to the link over here. You can copy the link over here, and you can run a simple command called git clone and just paste the link. So what that does is it clones the repository onto your local system. Now you can see it says it cloned the repository into a folder called Next.js -demo. How you can what you can do now is you can navigate to this directory by setting the current directory to Next.js -demo. And if you have VS Code installed on your system, you can run something called code space dot, which basically means open VS Code in the current working directory. There is a simpler way of doing this as well. So basically, if you're not that familiar with the command line interface, you can basically just open a new VS Code window. You can head over to the File tab. You can click Open Folder, and you can try to find wherever this folder was cloned on your machine. So the initial folder structure might look a bit intimidating. There are a lot of files. We won't have to deal with all of the files today. So readme.md is basically a description of your repository. Since we have installed Tailwind, there is a tailwind config.js file. So this file basically just says whatever Tailwind should basically tell Tailwind that we need to look at certain pages in our repository. So for example, there is /pages **. So what that means is everything in the pages folder should be looked by the Tailwind compiler so that it knows that it needs to apply styles to these files. What the theme does is Tailwind has an extensible API. So basically, other developers can create themes for Tailwind, and you can import the themes directly by adding the names in the tailwind config.js file. What the pre-flight false is doing is that when we install Material UI and Tailwind together, there is a slight fight between the two libraries for precedence. So what we do is we just tell Tailwind to not fight with Material UI, basically just install its script after Material UI is done injecting its scripts. And what this important tag does is it just separates everything that falls under Tailwind from Material UI. What the post css.config file does is it just says that we have Tailwind set up in our React project and just compile the Tailwind CSS into normal CSS when we actually build the application. What the package.json file is it basically has all the scripts that are available for us. So what kind of scripts we can run? So basically we can run the development server, or we can deploy it later, or we can lint the code. Linting is basically just going through your file and searching for errors in your logic or syntactical errors. Sorry, dependencies. So this dependencies section just tells React or Next.js in this example what all dependencies are required for this project to work. Dev dependencies are similar, but they're run on the server instead of running on the build time. Now, package.log.json file, you don't have to worry about it. It's an auto-generated file. Next config.js, again, you don't have to worry about this right now, but it basically says what all configurations you want to apply for your Next.js project. Getignore file is just a file that says what all files you don't want to push to GitHub later when you upload your files to GitHub. GitHub is basically a code sharing platform where you can share your code. You can integrate it with other services like hosting platforms or databases for continuous integration, CI/CD, for example. So we'll mostly be working today only on the styles folder and the pages folder. So the pages folder in Next.js is where all your logic for the front end goes into. The styles pages is where your CSS lies in. By default, Next.js gives you a global.css file which applies all the styles globally. So whatever you write in here is applied globally to all your Next.js components. So the default template, if you have cloned it properly, there are 2 steps you would have to do before it actually starts working. So you can head over to your terminal and you can run a command called npm install. So what this command does is just tells npm, which stands for Node Package Manager, to install all the required dependencies for your project. So as we saw in the package.json file, there were a few dependencies we defined, like React, React DOM, and Next.js, for example. So what this command does is it fetches all those packages and puts them into a folder called node modules. So node modules is basically all your dependencies for your project. Now the next step to actually run your Next.js app is running the command npm run dev, which was also defined in the package.json file if you look closely. What npm run dev does is it runs your Next.js app on a localhost server. So you can head over to this link. So if you have a Mac, you can command and click on the link. If you have a Windows PC, you can just control and click on the link. So control clicking on the link should open up, or you can just copy paste the localhost 3000. So what that does is it should open up your Next.js app on your browser. So once you visit the URL, it should compile everything on your server. And if you cloned everything correctly, you should see a basic button just saying welcome to GDSC that's entered on the screen. Now let's look at how we define this button and how we put it on the center of the screen. So if you head over to pages and index.js under pages, so this is where all the logic for everything that's rendered on the index. So index.js is basically the landing page. So whenever someone visits just your website without any extension, without any endpoint, they're presented with whatever is written inside index.js. So what we're doing here basically. So since we have installed Material UI, we can import a button component. So since we have installed Material UI, we can import a button component inside inside the file, and we can then use the button component just as we would use any HTML tag. So basically, we call button, and we can set some properties for the button. So we are saying that the button should be of a color primary. So with Material UI, if you read through the docs, there are some predefined styles that you can apply to any component. You can look through the API for the button on Material UI to know what all different properties you can set to your components that are imported. If you have the extension pack installed that was shared with you, you can basically hover over any component in VS Code, and it should give you a short description of what that component is. And you can even it will even provide you with the API link, so you basically can go to the API and read about what props are basically arguments in Material UI. So you can basically see what props are available for a particular component and what you can change it to. So for example, in our case, we defined a property called color. So if you hover over color, it should show you a list of what different colors you can use for a button. For example, the default one is primary. So even if I didn't define this property, it would still render in the same way. But for example, if you wanted to change this primary color into secondary, for example, the secondary color is a purplish color, I believe. So if you type secondary, and if you head back to the website, you should see the color has changed to a different color. In a similar manner, there are different variants of the button by default. So for example, the default variant, I believe, is outlined. So the outline button is a different style of a button. It looks pretty different from a contained button, which was completely filled out. In a similar way, you can just hover over the variant property and you'll see different types of attributes that you can set for it. I believe there is a question. Is there a question? Okay, so now, for example, okay, so you might have noticed that there are different properties that we set in the class name as well. So this is basically where Tailwind CSS comes into play. So by setting certain class name properties to your element, you can define certain styling aspects of your component. For example, in this case, we have a class name of w-screen. What that basically tells Tailwind is that you want the width of your div to be the same size as your screen. That is 100 VW. VW in CSS stands for viewport width, which basically means 100% of your screen. You can even hover over if you have Tailwind IntelliSense, which is an extension of VS Code installed, you can basically hover over different class names. If you give a particular class name that Tailwind CSS understands, it can give you a definition of what it's doing behind the scenes. So what it does internally is it sets the width of the element to 100 VW. So yeah, so in a similar fashion, we can do something like h screen, which is basically height. So we are setting the height of the component to the entire screen. But this alone is not enough to center whatever we had put inside, like which was our button. To center the button, what we had to do was introduce something called flex. So if you read more about CSS, there is a property called flex. Flex basically creates a flex box, which you can use to manipulate where an element is placed on the screen. So what we do is we set the flex, which sets our display property to flex in CSS. Then we use two more properties, justify center, which justifies all our content to the center of the screen. And we use item center, which is another property provided by Tailwind CSS, which aligns the item to vertically center on the screen. So this is all the Tailwind CSS that was used to vertically center our button on the screen. Don't worry if it looks intimidating right now. If you build very basic HTML components with CSS, you will start to figure out how it is very easy to just implement the same thing in Tailwind CSS. So class name, again, for the button, we set certain properties like p-8, which is setting the padding of the element to 8 pixel. So over here, the 8 is not relative to any browser CSS value. It is just predefined. It's just a predefined way to mention that you want the padding to be bigger than something that's lesser than 8. For example, you can have padding 6, for example, which will reduce the padding, which is how much the screen is padded, how much the button is padded. Now what text 3XL does is it sets the text to a bigger font size. So basically you're increasing how big the text is. You can mess around with these values. You can try changing it to 2XL and see the text go down, or you can try something larger like 5XL and it should automatically grow. Now what rounded does is it adds like a border radius, so it makes your button more rounded on the edges. So instead of 2XL, if I wanted a more rounded edge, I could do something like 4XL, and I think 3XL is the biggest rounding you can do. Yeah, so you can do something like 3XL and it should round the button more. Now say you wanted to use the same button multiple times in your app. How would you do so? So the very basic way of doing it would just be to copy the thing and paste it twice. Although this works, it's not very developer friendly in the sense, suppose you had like 10 buttons, you would have a lot of extra redundant code that would not look very nice. It's not very easy to understand either. So now let's see how we can make this button into its own component. A component is basically just a piece of code that you can reuse later in your app. So to convert this button into a component, what you would do is uh, so to make everything more organized, what we can do is we can create a new folder called components, for example. We can create a folder in VS Code by using the button on the top, on the second button on the top. It says new folder, or you can even right click anywhere and you can, I believe you can create a new folder if you click outside. Okay, another way to do it is by, I think, uh, it's in one of these options where you can create a new folder. But once you're done with creating a new folder, we'll add a new file to it. So for this, so we are creating a custom button. So let's just call it custom button.js. So remember, since we are using React, even though we want to have something that looks very similar to HTML, we would still have to create a JavaScript file. Uh, So if you have all the extensions installed, there is an extension that helps you with code snippets. Basically, you don't have to type out the whole thing every time. There is a short form of writing an arrow component. An arrow component is basically something that runs a function. The function can be React code, it can be just JavaScript code. So what RAFCE stands for is the React Arrow Functional Export Component. It's basically a part of a code snippet library that was part of the VS Code extension pack. Uh, so once you run RAFCE, it will automatically generate some code for you. So this code generated is very basic. It has the name of whatever component you're using, a simple div with the same thing again, and you're just exporting the thing so that you can import it into other files. So now what we wanted to do was make this button into its own component so that you can use it multiple times instead of just duplicating the code. So what you can do is you can take the same code here, and instead of returning the div, you can now return the button. But the problem with this approach is we haven't told React what this button is yet. So to fix that, we can use the same import function we used in this file. So we are importing the button from MUI's material library, and just put it at the very top. And now we have created a new component. But now, although we have a new component, there is no way for React to know that we want to render this component onto our page. So how we can do that is in our index.js file. Now that we have created the same component in a different file, we don't need this boilerplate code. What we can do is, since we called it a custom button, we can start typing custom button, and VS Code by default recognizes that as a component, and it will suggest that you can auto import it. So if you click on that, uh, it didn't auto import it now, but how you can import the custom button is by saying import custom button from, and then you just mention where you want to import it from. So if you're not familiar with the relative links or relative location of files, basically two dots says go one folder higher in the parent in the hierarchy. So basically we have index.js under the pages folder, right? So if you want to go outside the pages folder, you type dot dot, it basically jumps you outside the pages folder, and then we have access to all the other folders. So you want to go inside components folder, so you simply write /components, and now inside the components folder we have a custom button file. So you just write a custom button, and that should import the React component into this app now. So you can see after doing all that, we still have the same screen, which means the button was successfully exported from that file and imported in this file. How you could test that is basically having two custom buttons instead of one. And you can see both of them got rendered on the screen. Now, if I wanted to have the buttons vertically, display vertically instead of horizontally, what I could do is, since this is a flex box, I could just justify that I want my flex to be in the column direction instead of row, and my buttons will be displayed vertically. Now, even though I have multiple buttons, they don't have any spacing in between. So to make it look fancier or add more spacing, you're supposed to add something called a margin. So uh, margin basically stands for spacing between components. So in Tailwind CSS, there are multiple ways of doing this. You can either say margin, a short for margin is just M, and hyphen how much ever margin you want. So M2 stands for margin in all directions of 2. If you hover over the thing, you can actually see how much margin it's actually putting. It's putting 8 pixels of margin on either side of the button. Um, Now, if you want, this is not ideal since it's even putting the margin on the left and the right hand side. You can't notice this because it's centered on our screen, but when you have other components, it will put unnecessary margin on the left and the right. So to avoid this, you can even specify the direction in which you want to put your margin in. For example, if I just wanted to put a margin in the Y direction, Y is basically vertical. So I could do something like MY hyphen 2. It doesn't change anything on the screen, but internally it only put margin on the top and the bottom instead of putting it on all sides of your component. So now moving on to how to make this more interactive. Basically, how do you use the same component to render different states? So it's very rare that you'll have to use. It's very rare that you'll use the same button in multiple places. You might want to use the same button but with different text inside. For example, instead of welcome to GDSC twice, I might want the second button to show something else inside. So how do you do that? So if you notice how a normal HTML attribute is basically defining some property and then giving it a value. In a similar way, for React components, there's something called props. So basically, it's a very similar concept to attributes, where you can define a prop by giving it a name. For example, in our case, let's give it a name called title. We can set the title for the first one. Let's just call it Hello World or something. Now that we have set this title is now accessible uh, in our custom button folder, in our custom button component. How you can access it in your custom button is by, you can actually access it in multiple ways. I'll show you a couple. So for example, you can access it as a props variable. A props variable is like an object in JavaScript. It basically is like a dictionary. If you can consider it as a real dictionary. So for example, there are words and there are definitions for that word, for those words. In a similar way, in JavaScript, you'll have some keys that are the words, and the definition for the words will be the values for the keys. So for example, I have props over here. So if I wanted to access what was inside the props, so remember how we passed a title thing, title equals something to our custom button component. Now the way you print that out in your in your actual component is by accessing the props dot title property. So what this does is since we passed hello world for the first one, it renders hello world out, but for the second one, we didn't pass any title, so it renders a blank button. How we can fix that is by using a different approach. So instead of just getting all the props as a single object, we can destructure it. Destructuring is basically a principle in JavaScript where you can get specific keys from an object. So what we do is we make the use of curly braces over here. So anything inside curly braces, whatever names you define in here, you can separate them by commas, and those will be the keys you want to use in your React component. So for example, we passed in the title, so we can use something like title. We can directly access the title from the props we passed, and instead of using props.title in the React component, we can simply use title over here, and it should do the same thing. But now it's not a very good practice to have empty buttons. It won't make sense to the user. So to fix that, we can even give default values to your props. For example, let's give it a default value over here, and it renders the default value whenever a certain prop is not passed to a component. Now you can even edit the other properties of your components. For example, over here, as we saw, you can change the color of the button and how it looks. So we can even customize them by passing them as props. So for example, along with title uh, passed to our custom button, we can even pass something like color, and we can call it secondary for the first one, and maybe let's pass an error or something for the second one. Now in the same way we access the title, we can put a comma here and we can access the color property that was passed. And we can basically, instead of hard coding or basically just saying that everything over here will be of secondary color, we could make it dynamic and pass the color that was passed in through our component or functional call. So it will change on each instance of the custom button we defined based on whatever we pass to the button. Now, in a similar way, we can even edit the variant out. So, for example, instead of just being outlined all of the time, we can call a variant prop over here, and we can, in the destructuring over here, we can also tell React that we expect another variant prop. Uh, and if you go back to your index.js file, uh, again, like another attribute or prop in this context, we can pass a variant that will be primary. Oh no, I mean variants are like contained, for example, for the first one, uh, maybe outlined for the second one. So that would customize your button based on whatever properties you pass to your button. So now let's move on to actually building what we meant to build. Uh, so Yep. So let's try to code this out. It's basically using Material UI's card API. So they have a card API which basically provides you with a card header, card media, and card footer, or card actions, I believe it's called. Um, so what it does is it exposes you with a certain component that you can pass in different props or attributes, which will modify the way it looks on the user screen. Um, so let's So to do that, let's now create a new file in our components folder. So you want to make a new component. Every time you make a new component, you create a new file. So I think there is a question. Why is there HTML code in a JavaScript file? It does look like HTML, but it's not exactly HTML. This is JSX. Um, it helps add more interactivity to your website, make it make it more lifelike. Basically, you're adding JavaScript code inside HTML, which helps you to uh, define some sort of uh, what it enables you to do is you can add like certain event listeners. For example, you can add on click. For example, on click is basically an event listener which listens for a click event. So when someone goes on a button and clicks it, an on click event listener is called, and you can execute JavaScript code inside that, which can update the user interface. So now let's build out a card component. So let me call it custom card.js. Now again, like the previous custom component we made, we can make use of the RAFCE short form shorthand thing, which creates some boilerplate code for us, saves some time. So now let's import a card from Material UI. So the way you do that is write something like this. So you write import card from material at the rate at MUI/material/card. So what this does is basically telling React that you want to use the card that was defined by Material UI in your own app. So we can simply, instead of returning a div over here, let's return a card component, for example. So now inside the card, so in terms of component-driven development, there are always smaller components that you would want to nest into your bigger components. For example, the card can have multiple smaller components. Like the card we saw, it had a header that had an image and like a name and the time displayed. It had a media component, which was basically the image, and it had actions in the bottom, which were like for liking and sharing it, for example. So how you can do that is by importing the sub-components for the card API. So for example, there is another uh, component defined in Material UI, which is called card header. So what the card header is basically an abstraction for a card header which accepts different props, and the user interface changes based on whatever is put inside the card header. So what you can do here is now inside the card on the very top, you want the header to be displayed. So you can do card header, and the card header basically takes in certain props. So for example, there's a avatar prop, which basically is the image on the top left of the card header you saw. Now to add an image on the top, Material UI even provides you with an avatar prop, which you can access by simply typing that. So what this prop takes in is a React node. So what we haven't explored yet is basically, so far when we were talking about props, we were just passing strings around. But props are much more than that. You can even pass in arrays, for example, or you can even pass in React components itself inside the props. So over here, you could have a complete React component as an argument passed to the card header. So for this, the avatar prop basically takes a source. A source is where the image for the avatar can be found. So for our case, we can use Unsplash. Unsplash is basically an image hosting service. It provides you with free and open to use images. It's basically like a stock image platform, but the images are free to use. So they have a specific URL which you can generate. So what this URL says is that you want a random image every time of the dimensions 300 by 300, and it should be of a person. So far you can't see whatever is happening here. So for example, if you want to import this into your actual page and display this out, you can do it in a similar fashion to what you did with the custom button. So you would have something like import custom card from, and then you try to point to the card. So you go a directory up, and then you can see there's the components folder where all our components lie. And inside the components folder, we again have two things, custom button and custom card. So we want to import the custom card. And now what we can do is we can place the custom card inside our main div on top of the custom button. So you can do that simply by writing it out like an HTML tag by doing custom card. And it's a self-contained element, so you can just close it out. So far, you can only see the image because that's the only thing we have defined so far. Um, so to add more stuff to the header takes two more arguments. One is the title, one is another one is called the subtitle. I think it's called subheader. So over here, you could pass in the title equals, and you can give a title. So whatever person's name, for example. So what this does is it prints out the title next to the image in your header. Now, in a similar way, you can have a subheader. It's called, I think, yep, subheader, and that would be so. In practice, when we actually implement the web app and when we will have like data coming in from a backend, we can actually calculate the time, or like we can actually calculate when the post was made, for example. But for now, let's just have like a fixed subtitle, for example, 10 minutes ago or something. So that gets printed as a subheader. Uh, now, what we want to do is we even want to make our card a bit wider. Right now, it is only of the width of whatever content is inside it, but we want to have a predefined width for the card. How we can do that is by adding styles to our main card component. We'll use Tailwind CSS for this again. So we define custom classes. So Tailwind basically supports multiple classes to define the width of your content. So in this case, we can have a width of say uh, 80 something, 80 for example. So the card gets stretched to 80 pixels. Uh, to have a more well-defined shadow over here, Material UI also provides you with an elevation property. Elevation is basically how elevated the card should look. It's a number. It basically takes a number from, I think it's from 0 to 20 or something. So if you pass in 20, you can see the shadow behind the card is more defined now. So it looks more elevated. Now, if there is no spacing between the button and the card, you can do that by adding a margin to the bottom, which you define by MB in Tailwind CSS. So you can say margin bottom, say 4, or if I want like 8, for example. So it will set a particular margin below the card so that it is separated from the buttons and it's easier to distinguish different parts of your UI. So now what the card header provides us is with another thing. It's called an action. An action is basically a button towards the very far right of your header. So for an action, we can basically have anything in an action. For starters, we can just have a div that just says something, and it will be put at the very end of the card. But for example, as in the design we had, we would want to put something like 3 dots on the top right. Uh, how we would do that is by importing something called an icon button. So an icon button is basically a button that can have just an icon within it. Unlike the normal buttons we have to put text inside it, but an icon button will enclose an icon. We'll use Material UI icons for this. MUI icons, we can import an icon called more vert icon, I think it's called. So it's basically the 3 dots that we see. Now, how do you find these icons? You can simply go to the React document, the Material UI documentation, uh, and if you head over to Material icons, they have a search functionality where you can just put in whatever icon you're looking for. So suppose I was looking for the 3 dots icon. So it gives you with a variety of icons you can use. They have variations as well. You can have outlined icons, you can have rounded icons, or you can have two-tone, for example. Um, how you can import this into your React app is by clicking on whatever icon you like, and it will basically provide you with whatever code is required to import that particular icon in your React.js app. So you can just click on it, it automatically copies it to your clipboard, and what you can do then is you can just paste that in your React app and it should import that icon for you. So now let's, instead of printing out the hello div that we did for the card header, let's just print out an icon button, for example. So an icon button and the closing icon button. And inside the icon button, let's inside the icon button, let's just enclose our icon. So the good thing about Material UI icons is that you can just use them as any other component you would use in normal React. So for example, you can just type in more vert icon, that's the name of the icon. And it should automatically put that icon inside the icon button. So what that looks like on your actual website is that it gives you a button on the top right that is clickable with a animation as well. When you click, it gives you a ripple animation, for example. Yep. So now let's move on to the actual media component of the card. So we are done with the header. So we have a proper header with a picture which is randomized. So every time you refresh the page, the image that is shown is of a different person. That's just something that Unsplash provides you with. Now, the way you add the image in the card is by using the card media component that's provided by Material UI. So you can just import card media, and following the card header, you can just use card media. Okay, now what card media takes is um, a few properties. Firstly, you have to tell what kind of media you have. So in our case, we have an image. So we can just say that we want to render this component as an image. Secondly, it takes what image you actually want to render. So we can just do img equals, and I think it's image. So you can just do image, and you can just pass in whatever source of the image is. So in a similar way, like the Unsplash API, we can just use the same API again. We can just change the link so that the image is a bit bigger this time. We can just use that over here. So what that link basically is telling is what the link basically is doing is it's going to unsplash.com. It's getting a random image that is of size 1280 by 720. So basically 720p image. And the question mark, anything followed by the question mark is just telling what category of images you want to search for. So basically I just want a scenery. So I just define a scenery to be randomly imported as an image. Another thing which is a good practice is basically defining an alternate for the image, an alt tag. So for some devices, maybe they have slow internet or the image can't be loaded. What an alt tag does is, even for screen readers, an alt tag basically defines what's supposed to be there if something is not rendered out. So over here, I'll just say post image, for example. Um, Although you can't see anything change on the screen, what that did is it added just a metadata sort of thing for the component, for the image component. So when a screen reader goes through your component, it can say that at this point there was a post image. So now finally, if you look back at the design, we have a footer with a description, and the description is followed by a few buttons. How we can do that is by importing something called card content in the same way we imported card header and card media. So card content. So how we use card content is also similar to the other components that we imported from Material UI. So you just mention that you want card content. And Material UI basically comes with its own set of rules of how to display text. So anything you put inside a typography component, basically you can import typography from Material UI as well. So you can just say typography. So anything put inside typography is follows the rules of material design. So inside your content, you would want something like typography. And inside typography, you can just put in whatever text you want. So for example, welcome to GDSC, for example. This is a custom card. So what that does is it renders it out as a description. This still doesn't look quite the same as what we had in the preview image. So what we can do is we can change what kind of typography we have written inside. So how we can do that is by changing the variant property. So variant. So if you hover over variant, it will show you different types of variants for the typography component that you can use. For example, we'll use the body2 typography thing, the typography variant. So we can do we can just do typo variant equals body2. And yeah, that basically made the text a bit smaller. So it's a smaller version of the body text. Now we even want to change the color of the text to be slightly dimmer because it's very dark right now. How you can do that is by changing the color property, and you can set the color to the secondary text variant. Should be in quotes. So that makes the text slightly dimmer, not as bright, not as dark as before. Now we are done with the description, which was the card content. Now we move on to the bottom bar, which basically are the buttons on the left and a counter on the right. So to implement that, we can import something called card actions, I think. Or yep, it's called card actions. Now we can use the card actions is also the same. Just type in the name as a component, and now in the card action, we can have a main div. So inside the div, we have a couple of things. If we it's card actions. Yep. So we can have a couple of things in the card action. So if we look at the design again, we had the two buttons on the left and something on the right. So how we can do that here is by creating a bigger div. So basically a container for everything. And inside that, we can have two smaller containers. So we could have something like a div here and another div following it. So in the first div, what we want to have is basically an icon button again. Icon button. And let's look for the heart icon, for example. If we want, we can just go to the material UI icon button. So and look for a heart icon here. It's called favorite. So you can just copy that. And in a similar way, at the very top of your app, you can import the button as like so. And then you can use the icon button, and you can use the icon inside the icon button component. So what that does is hopefully add the icon button on the bottom action bar towards the left. In a similar way, we'll have another icon button under the same div. But instead of the favorite icon, we'll have the share icon. So how we can find the share icon is going back to Material UI docs, search for share, and there the share icon, you can just copy that. and you can replace this with share icon. So what that has done hopefully is added 2 buttons on the left side. Yep. And now we want to add like a counter over here. So for example, it was 1 in the example. You see it doesn't get added where we want it to. So how you can fix that is by, again, defining a flex box. So what a flex box does is you can place content in a orderly manner. We can again use Tailwind CSS for that. You can define the class name. You can say it's a flex box, and you can say that you want the flex direction to be of a row, which it already is by default. And what you want to say is that you want to justify the contents. You want to have space in uh, between the div that holds the 2 icons and the number. So how you can do that is you can basically just say justify between, which basically spaces or puts space in between the uh, oh sorry. So you have to put these tiles under. You have to put these tiles under the card actions basically instead of the div, and you don't need the wrapping div. Yep. So that puts some space between the card actions and the number. Now, if you want to vertically align the one with the vertically bigger icons, you can either change the size of the text. So for example, I can use Tailwind CSS again. So I can say class name, and then I can say text to be 2XL, for example, or 3XL. And you want the text to be slightly towards the left. So basically you have more margin to the right of the text. How you can do that is by adding a margin right of say 3 for the text. So it's not just sticking towards the right of the card. Now in our example, we even had the whole card a bit more rounded and the edges. So how you can do that is by heading over to the main card component. It's at the very top of your React component, and you can say that you want the margin, or you want the border to be rounded. You can do that by saying border rounded, and whatever how much ever rounded you want. So the maximum rounded it can go is 3XL, for example. So that adds a rounded edge to the entire card component. So at this point, we have pretty much recreated the same card component, complete with a image as well as icon buttons. Now this could be done in pure HTML as well. So why use React? So what you can do with React is basically bind events to buttons, or like add interactivity to buttons. How you can do that is by going into your like button, for example, or the favorite icon, and you can say, for example, on click is an event, and when you click on the button, you want something to happen. So what you can do is you can call a function on click. So for example, uh, increment like, for example, it will still complain about it because the function is not defined. Now you can define the function is by going before the return statement of your custom component. And what you can do is you can define a const, which stands for a constant, and we called it increment likes, I believe. Yep. So we can call it the same name, increment likes. And what increment likes will be is basically an arrow function. An arrow function is very similar to a function in React with some basic differences. So what increment likes should do technically is increase this number on the right hand side. For now, we had hard coded the number 1 inside the div element. So to make it more dynamic, we can go back to the concepts of hooks in React. So we can use a very popular hook in React called useState. Basically, it maintains a state for any variable you have that can update the user interface on the state change. So you can import that from React as such. And to create a new state variable, you can use array destructuring, which is basically having something like this and use state at the other end. So what useState returns is two values, a variable and something to set the variable. So it's a common convention in React to have the name of the variable and the setter of the variable basically have set and the name of the variable after it capitalized like that in camel case. So basically what this did is create a state likes and gave us access to a function called set likes, which can update the likes variable. What another thing you can do with the hook use state is that you can set a default value for your likes variable. So you can set it to 1, for example. And what that did is gave us a variable likes. So now instead of having an hard-coded 1 over here, what you could do is use the braces, which stands for JavaScript inside JSX, and you can simply pass in the variable likes over there. Now, if you remember, we defined this onClick function, which calls the increment likes constant that we defined earlier. So now what increment likes should do in theory is change the number or update it by 1 every time you click the favorite button. So how we can do that is by calling the set likes method and by incrementing the current amount of likes by 1. So you can just say likes plus 1 inside that. So what this did is take the current amount of likes. So for example, when you start off, there'll be 1 like. And when you click on the button, it should read the current value of the likes, that is 1, and add 1 to it and save it. Now, if you click on the button, you can see that the number goes up. That means that state is being updated and React renders out your new state. What else can you do? You can even add alerts. It's not really recommended, but you can, for example, if you wanted to alert the user that your post has been shared successfully, you can use the window method alert. You can just say shared successfully. What this does is when you click on the share button, it should alert me with whatever message I put inside. Okay, now in the example, we saw that the color of the button changes as well. How do we do this? So the favorite button also takes in a property called color. So we can set the color by default to error, which is red. So this will always be red. But what we wanted to do is when you click it once, it changes from gray to red, and when you click it again, it changes back from red to gray. So how you could do that is you can use something called ternary operators in React. If you're aware of if conditions, what an if else is, a ternary operator is pretty similar to an if else condition. Basically, you give a condition. If the condition is true, a particular value is returned. If it is false, another value is returned. So how you can implement that here is basically saying that if my likes, the percentage sign in JavaScript stands for a modulo operator. It basically divides a number by something else and returns the remainder. So if you do likes modulo 2, it basically divides the likes by 2 and returns the remainder. So if your number of likes are even, for example, it will return a 0 because an even number divided by 2 will have no remainder. When it's odd, it will return a 1. So we can use that to check. We can basically use that to alternate between two states of our component. So when likes modulo 2 is in JavaScript, if you want to compare two values, not just by reference, but by value as well, you can use the triple equal to sign. So here we are saying if the likes modulo 2 equals to 0. So basically, if the number that's displayed is even, if it's even, we want the color of the favorite icon to be of the error color, which is basically red. Otherwise, so in a ternary operation, the question mark stands for the true value of the if condition. So basically, if the likes modulo 2 equals to 0 is considered as our condition, so if that condition is true, error is returned. But if that condition is false, the value that we defined after the colon is returned. So we can basically return inherit, I think, or default. So what that does is by default, it's a gray button, but when you click it once, the color changes to red. When you click it again, it should change back to gray and so on. So you can just toggle the color of the icon. And finally, let's make a small menu that comes up when we click on the top right button. That's usually how it should interact. So to do that, what we can do is import something called a menu. A menu is another thing Material UI provides you with. So you can import menu, and you can basically, whatever falls under a menu is considered a menu item. So you can import a menu item as well. Now, if you want to make a menu, when you click on the icon button, you basically have to wrap it around in the same div. So how you can do that is create a div, wrap your action inside the div, and basically have your menu pop up when you click on the icon button. So Material UI is smart enough to recognize that there is a menu item with the button component, and whenever the button is clicked, it automatically enables the menu. So basically, for the inside the menu, you want certain menu items. So inside the menu, for example, you want a menu item of say item 1, for example. But when you click on this right now, you'll see that it doesn't pop up anything. That's because we haven't told React when to actually show the menu and when to not show the menu. So to do that, we can define another state variable like we did for the likes. And we can do so by calling, by using a similar syntax. For example, you can say open comma set open equals use state of false, for example. And then on click of the icon button, so basically when you click the 3 dots on the top, it should open the menu up. So how you can do that is by going onto the icon button and adding an event listener of on click to it. So you're basically saying whenever this icon button is clicked, you need to run a certain function or a certain action. So the action in our case is setting open to true. So that's basically telling React, not really true, but we have to set it to the reverse value of whatever open has. So for example, if open is true currently, the exclamation sign stands for a not operation. So not operation. So if you have a true value, an exclamation true will return not true, basically false, or an exclamation false will return a true value in a similar way. So what we are saying here is whenever the icon button is clicked, you set the open value to the opposite value of whatever it's currently holding. So even after doing this, we won't see the menu because we haven't really specified when to open the menu. So to do that, you can basically set the prop value of open to our open value. So what this should do is whenever you click on the 3 dots, it opens a menu, but it's not placed where we want it to be placed. It's placed randomly on the screen. So how do we actually link our icon button to the menu uh, is by setting a reference to it. A reference in React is basically uh, wherever the element is present inside the DOM. So in a we can in a similar way we define the different use states. We can define another use state for the reference. So we can call it button ref, for example. We can define a function to change it. So set button ref, and initially we can just set it to null, basically saying it is not defined initially. But when we click on the button, we want to set the reference to our three dots, or like the icon button. How we can do that is in the same action when we are clicking. After setting it not open, we can even set our button ref to event dot current target. So this is basically JavaScript notation to say that we want to select the current target. Event is something we get as a argument whenever a click function happens. Since the click function is an event listener, the DOM passes you an event a dictionary or an object that has various properties you can use. One of them is the current target property. So if now we even need to tell the menu what reference to look for to bind to. So basically we need to tell where it needs to render the menu out. That is pretty simple. What we have to do is there's something called anchor EL, which basically stands for where the anchor for the element should be. So in the menu prop, we can set the anchor EL property to our button ref. So doing that, now brought our menu up to the correct three dots. So basically, that was how you add a menu to three dots. To close the menu, we need to add another action. So basically, when we click on any of the list elements, we want the menu to close. How that can be done is by adding another onClick event. So onClick, what you can do is you can set the button ref to null again. So basically telling that there is no reference anymore. And we can even set the open property to false. So what this onClick event is basically doing is whenever you click on a menu item, it should close the menu out. Now, if you want to render out multiple menu items and you don't want to rewrite the code for each item, so basically suppose I wanted item 2, item 3, and so on, what I could do is I could use JavaScript arrays and I could loop over them. So what an array is basically a collection of anything. It could be strings, it could be other objects, it could be arrays itself. So you can have multi-dimensional arrays. But in our example, let's just use strings, for example. So if we had item 1, comma, item 2, and item 3, for example. So what JavaScript provides us is with the map function, which basically loops over this array, and for every element in the array, it will return a value, which we can call item, for example, over here. This again is a function, and inside the function, we need to return a value. So instead of, so right now it will just not render anything because we are not returning the menu item. What we can do is just return the menu item here. And it displays 3 items, but you can see the name is not changing in the menu item. So what we can do is, instead of using item 1 as a hard-coded value here, you can use the item that is passed on by the menu function. So there we go. We have made our very first React component from scratch using Material UI and Tailwind CSS. What I would encourage you all to do is go through the documentation for Material UI as well as Tailwind CSS. Familiarize yourself with basic JavaScript notation, CSS, basics of styling your components. So when we do our next session, we'll be moving on to more complex interactive components, as well as building our UI in a way that that is responsive as well as is dynamic. We'll also be connecting a backend to our web app in the next session. So if I go back to my slides, yep. So it's your first time learning React.js. You might be wondering why we had so much HTML like JavaScript. Why couldn't we just write it in an HTML file? It was because there were multiple JavaScript interactions in between that made our components more dynamic. So yeah, in our next session, we'll be covering the file-based routing system, which is provided by Next.js, as well as file-based authentication. Yep, thank you for attending, everyone. Looking forward to the next session. I guess.
Thank you, Gaurav. Thank you, Gaurav, for a lovely session today. We hope to see you guys in the next one. We'll be posting the next updates on the next session. This is Google Developer Student Clubs here at Heriot-Watt University, taken by Gaurav, the one and only. We'll see you guys in the next one. Thank you so much. Have a lovely day.
Thank you, everyone, for attending.